Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy variant is called Tulip by Vortex, and here are the rules. And we've got a nice little tulip here actually as a drawing, which is pretty cool. Anyways, the rules are normal Sudoku rules apply. The digits 1 through 9 appear in every row, column, and box. We also have German whispers, where neighboring digits along a green line must have a difference of at least 5. So for example, if this were 3, this would have to be an 8 or a 9, because the only digits that are 5 or more away from 3 is an 8 or a 9. And that's how German whisper lines work. We also have region sum lines, where box borders divide blue lines into segments with equal sums. Well, we only have one region sum line, so therefore the box borders would divide this line into these two digits, these two cells, and these three cells, and then this single cell and this single cell. So all those segments, this single cell must equal the sum of this single cell, which must equal the sum of these three cells, which must equal the sum of these two, which must equal the sum of these two cells. And that's how region sum lines work. We also have Renban lines, where digits on a purple line form a set of consecutive, non-repeating digits in any order. So you cannot have repeats on a Renban. Well, okay, you couldn't have repeats anyway here. But for example, you could have something like, I don't know, 1, 3, and 2 here on this Renban line, and that would work. Or you could have something like 4, 5, and 3 on this Renban line. Or you could have something like, I don't know, 9, 8, 7 on this Renban line. As long as they are consecutive, they form a consecutive set, and they are non-repeating, that fulfills the Renban requirements. And that's how Renban works. And then finally, we have crop key dots, where digits separated by a white dot are consecutive, and digits separated by a black dot have a 2-to-1 ratio, and not all possible dots are given. So for example, if this were a 4, this would have to be a 2 or an 8 to maintain the 1-to-2 ratio. And if this were, say, a 3, this would have to be a 2 or a 4 to make sure that these digits are consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, I'm armed with my brain juice, so it should hopefully take pretty quickly. Okay. First thing that I see immediately is we have 3 cells which are separated by 2 black crop key dots, which means we have one digit that is in a 1-to-2 ratio with 2 other digits, 2 other unique digits. And the only possibility for that cell must be 2 or 4, right? 2 can be in a 1-to-2 ratio with 1 and with 4. 4 can be in a 1-to-2 ratio with 2 and with 8. Either way, in this row and in this box, you know the 2 and the 4 have to be in one of these 3 cells. So this is a 2, 4 either way, and this could be 1, 2, 4, or 8, and this could be 1, 2, 4, or 8. But the thing is, okay, on a German whisper line, if you have a digit that's a low, what digits are next to the digits 1 through 4, which we consider low? If you take a 1 and you add 5 or more to it, you get 6 or more, which has to be next to it on a German whisper line. So therefore, if you have a 1 through 4 digit, the digits that can be next to it are specifically 6 through 9. And if you take a digit that's from 6 through 9, take the highest one, which is 9, subtract 5 or more from that, you get 4 or less next to it. So therefore, a digit next to a 6 through 9 has to be 1 through 4. So always alternate between low digits and high digits here. So say whatever digit this is, we'll just mark this as yellow. This has to be the opposite set. So we're going to mark that as pink. This is yellow. This is pink, and this is yellow, pink, yellow. Now, interestingly enough, that means in this box, we have 3 of the yellow set. If this were a low digit, the problem is, okay, what are the possibilities for this cell? If this is 1, and this is 2 and 4, the problem is these also are low. And we already have 1, 2, and 4, which is 3 low digits in that box. So this can never be 1 in that case, because there would have to be 5 low digits in the box, which is not possible because the set is 1 through 4 for low digits. So 1 does not work. If this is 2, this could be 4 and 8, and this would be possible because we would only have 4 low digits in box 9. So 2 is possible here. If this is 4 here, this has to be 2 and 1 to be there. But the problem is you also have 3 low digits already, and then the yellows mean that you have to have 2 more low digits in this box, which is 5 low digits in the box, which is not allowed. So this cannot be 4 here. So either this is 2 or this could be 8, right? If this is 8, this is 4 and 2, we have 3 high digits that we can account for in this box. So this is either 2 or 8. This then has to be a 4, and this has to then be 2 or 8. Which means we have a 2-8-2-8 pair in the box here. That means this must be between 2 unique digits. So it cannot be 6, obviously. It can't be 1. It has to be 1, 3, 7, or 9. It cannot be 2 or 8 because of the 2-8 pair in the box. This digit must be in between 2 of the other set on a German whisper line. 2 unique digits on a German whisper line. So this cannot be 4 or 6. It has to be 1, 3, 7, or 9 because it can't be 2 or 8. So if it's 1, 3, 7, or 9, the digits that it can be consecutive with, well, it can't be 1 or 9 here. Because if it's 1 or 9, it must be consecutive with 2 and 8 specifically. But that's not allowed because of the 2-8 pair already in the box. Therefore, if it's 3 or 7, it must be consecutive with 4 or 6. Because again, 2 and 8 is not possible. But it cannot be 4 here. So it can't be 3 and 4. It must be 7 and 6. That's consecutive with. Therefore, all the yellows must be high digits, and all the pinks must be low. Therefore, since this is high, it must be 8. So this is 8, this is 2. These are lows. This is a low. This has to be high. This must then be a 9 here. This has to be, it's only between 7 and 8, so therefore it can only be 1. Can't be 3. The remaining digits are now 3 and 5 here. This is a low, but it cannot be 1 or 3, so it's specifically 2 or 4 here. This is a low. It's between 7 and 9, so it has to be 2 because it can't be 1. So this is 2. What else do we have? This digit is next to a 2 or 4, so it's 7 or 9 because it cannot be 8. This digit is the same as the sum of this digit, which is the same digit. So these two digits are the same, and they must be the sum of 3 unique digits, which means if you have 3 unique digits, the minimum of that sum is 1, 2, and 3, which adds up to 6. So this must be a high no matter what. It cannot be 6, 7, or 9. It has to be 8. So this is 8. This is then the 8, similarly. And this must add up to, must have a 1 with a 2 or 5 or 3, 4. This can't be 2, though, because of that 2. These add up to 8. These two digits add up to 8. It cannot be 2, 6. It could be either 1, 7 or 3, 5 here. Same here. It could be 1, 7 here, 2, 6 here, or 3, 5. One of these is a 1 here. So, either this is 2, 5, or this is 3, 4. This is in a 1 to 2 ratio. You cannot have 2, 4. You can't have 1, 2, because the 1 has to be on this region sum line. Therefore, it cannot be 2, 4. It can't be 1, 2. It could be 4, 8 as long as this is the 4 and that's the 8. Or it could be 3, 6. Well, the problem with this, then, is that it can never... Okay, not the problem, but if we try to make this 1, 3, and 4, that eliminates all possibilities for the cells next to the black Kropke dot, right? Because we've eliminated 1, 2, we've eliminated 2, 4. The only other possibilities are 4, 8, and 3, 6. If we had 1, 3, 4 be along this region sum line, that eliminates 3, 6, and it eliminates 4, 8. So this then has to be 1, 2, and 5 here. So this is 1, 2, 5. This cannot be 2 here. These digits are consecutive with 3, 6, or 8. It cannot be 2 because of the 1, 2, 5 triplet in the box. It could be 4 here, as if this is 6 and 3, that's 4. If this is 3 and 6, it cannot be 5, but it could be 7. And if it's 8, it could be 7 or 9. So that works for either. This must be a low digit because we only have low digits next to high digits on a German whisper line. This must be high, and this must be high, and this must be low then. Well, of these digits, which one's high? The only one that's high is the 7 here, which makes this 1 to add up to 8. This can't be 7 anymore, therefore it's 9. This is a low digit between 8 and 7, and there is not a 1 possible. Therefore, this must be a 2, which makes this a 4. And the 4 can be between next to a 9 on a German whisper line. This could be 1 or 3, because it's next to an 8 on a German whisper line. This can't be 7 or 8, but it's next to 2 unique digits on a German whisper line, therefore it must be 9. Which makes this a 1, a 3, or 4, but it can't be 1, 2, 3, 4. But it can't be 4 here. This can't be 3 or 5 because of the 3, 5 pair in the row. So this must be 1 or 2 to be with it. We now have a 1, 2, 5 triplet in column 2, which eliminates 1, 2, and 5 in the rest of the column. Therefore, this can't be 1, 2, 5. This can't be 1, 2, 5. Where is the 5 in column 2? It must be one of these two digits. Which means, in this box then, we cannot have a 5 anywhere else in that box besides those two cells. Therefore, this can't be a 5 here. These two digits are consecutive. And 3, the only two digits left of those remaining that are consecutive are 5 and 6. We have 3, 5, and 6 remaining. 3 is not consecutive with 5 or 6, so this must be a 5, 6 pair. Because of the 1, 2, 5 triplet in column 2, this cannot be 5. Therefore, this must be 6, which makes that a 5, which makes this 3. This 6 eliminates this 6, so therefore it's 7 and 1. And again, we knew that the 3, 5 were eliminated because of the 3, 5 pair in the row. This can't be 1 here, so this must be 5, which makes that a 2, which makes that a 1. What are the remaining digits? The remaining digits in row... So this is a low. These are lows. This is a high. And this is a high, and this is a low. The remaining digits in row 7 are 2, 3, 4, and 5. Well, 2 and 4 can't be here, therefore it must be a 3, 5 pair here, which means the rest of the row must be a 2, 4 pair here. The only digit remaining here is not an 8, a 6, which is high. And we have the remaining digits here being 8 or 9. Okay, let's see. If this is 9, that would force this to be 8, and that would eliminate all possibilities for any cell here. So this can never be 9. This can never be 9, but this could be 9 here. Where to go to next? Let's start coloring this German Whisper line. So this we're gonna make, well, let's make this orange, yellow, orange, yellow, orange, yellow. Okay. Does that tell us anything? Not particularly. Okay. These two digits are consecutive. What can the rest of the digits in this box be? We can have 3, 4, 6, 7, 8, and 9, right? But these digits cannot be 3 or 7. So this can't be 3 or 7. This can't be 3 or 7. This can't be 6. This can't be 8 here. If this is 9, this would have to be 8, but that's not allowed because we already have an 8 in the box, so this cannot be 9. If it's 4, it could be 3 or 5. If it's 6, it could be 7. If it's 8, it's 7. It can never be 9 because of this 9. So this is 3, 5, and 7 as a possibility. These two digits are in a 1 to 2 ratio. 1 has to be one of these 3 cells. That's interesting. So if it's 1, it could be 2 here. Right? If this is 1, 2, that makes this 4, which makes that 7. So this has to be a 3, 6 pair here. So this is 6 and 3. So if this is 1, 2, this is 7. If this is 1, 2, this is 4, which forces that to be 7, which forces this to be 6 and 3. And then the remaining digits we have left are 8 and 9. So this can only be 1, 8, or 9 here. Otherwise, it cannot be 2 and 4 because that would eliminate all possibilities here. If this is 3 and 6, this would then be 4, 8, which would force that to be 7. This would be 2, and that would be 9. So that works. So 3 and 6 works here too. It could be this is 4 and 8. If this is 4 and 8, that makes this 2, which also makes this 3, 6. That would make this 7. Is this always 7 then? Obviously, if this is 1, 2, this forces this to be 4, which makes that a 7. If this is 3, 6, that forces this to be 4, 8, which makes that 7. So far, this has always been 7. And if this is 4, 8, that makes this 3, 6, and that 4, 8 makes this a 7. So any way you cut it, this is always a 7. So this is a 7, which means this can't be 7. This is next to a 6 or an 8, which could only be next to 3 or 4 here. This 7 means this can't be 7, which eliminates 8 as a possibility. This could still be 4 or 6. Since one of these two digits is 4 or 6, and one of these two digits is 4 or 6, right? It's either 3, 6, or it's 4, 8 here. And this is 4 or 6, because this must be next to 3 or 5. Well, there cannot be another 4 and 6 in this box, which means this can't be 4 or 6. It has to be 9. This can't be 4, 6, or 9, so it's 3 or 8, which is fine. So this has to essentially be a 1-2 pair here, right? Because this is a 1-2 pair as 3 or 6. If this is 3 or 6, that's 4 and 8. If this is 4 and 8, that's 3 and 6, which is a 1-2 pair no matter what. Okay. Well, let's see what else do we have here. If this is 3, 6, this is 5. If it's 8, 4, it could be either 3 or 5. We know the rest of column 4 has to be 2, 4, 7, and 9. But this can't be 2 or 9, so this is specifically 4 or 7. And these must be 2, 4, 7, or 9. 9 cannot be either of these. 4 cannot be either of these. Okay. This could also be 4 and 8 here. So this could be a wide variety of things here. Um, uh, hmm. What are the remaining digits in column 5? Or not 5, column 8. Actually, we should look at column 5 eventually. Let's look at column 8 first, though. These have to be 3, 5, 6, 8, or 9. This can't be 9. This cannot be 5 because it's on a German whisper line, and 5 can never be on a German whisper line. Because if you take 5, you subtract 5 or more from it, you get 0 or less, which is not a normal Sudoku digit. If you take 5 and you add 5 or more to it, you get 10 or more, which is not a digit. So if this is low, this must be 3, which makes this 8, and therefore this must be 1 to 2 ratio 4. So 3, if this is 3 here, it can never be next to an 8 here because that would eliminate the 8, the 3 here, and that would force that to be 8. So if this is 3, this must be 9, but that's not possible. So this cannot be 3. It therefore must be a high here. So all the yellows, again, are highs. And all the oranges are lows here. So this is 6, 8, 9. This must be 1 through 4. And this must be 1 through 4. So this can never be 8 or 9 here, because you always have a low here. Oh, and this has to be high. Well, to get a Renban from the low to a high digit, that means it must, and it's only 3 cells in length, it must be 4, 5, and 6, right? To have a high digit, it's 6 through 9. To have a low digit, it's 4 through 1. So this must be then a low, and it has to be 4, which makes that a 9. That makes this a 5, because that's the only one possible to connect a low digit and a high digit through 3 digits. So this must be 6, which makes that a 1. This can't be 5 or 6. This can't be 5 or 6, and this can't be 5. These can't be 9 because of the 9 in the column. So we have a 3, 8, 3, 8 pair in column 8, which eliminates 3 and 8 in the rest of the column. That makes this a 6, which makes this 8, which makes that a 4. That 4 makes this a 2. This 8 makes this a 9. This can't be 8 or 9, so that makes this a 1, which means this has to be a 3, 6 pair. And this can no longer be 6 because of that 6, so this must be 3, which makes that a 6. That's 3 in the corner. We celebrate because we know we're getting close to finishing. This can't be 8. This must be 3. This must be 6. And the 6 can only be next to a 5 out of 3 and 5. which forces this to be 3, which forces this to be 5. These can't be 3 anymore. This can't be 1 because of that 1, so this must be a 2, which means this cannot be 2. This is 1 or 4. We know in this box the 9 has to be one of these 3 because in column 4, where is the 9? It's one of these 3 cells. So this can never be 9. It can't be 9 anyways. Therefore, this can't be 4. This must be a 1. This has to be 6, 7, or 8 next to this, next to both 1s. The 3 and 8 are only consecutive with 2, 4, but 4 is not allowed. 7 and 9. 9's not allowed here because of the 9 in the column. So this is 2 or 7. The remaining digits now are, what are the remaining digits in row 5? We have 4 and 8. This can't be 4, so this must be 8, which makes that a 4, which makes this 7. So none of these can be 7. In row 5, we have 3, 4, and 5 remaining, but this can't be 4 or 5, so this must be then 3, which leaves 4 and 5 in the row 5. This can't be 4, though, because of that 4, so this is 5, which makes that a 4. This 3 makes this a 1. The only remaining digit now is 6 in that box. And this is a 2, which makes this a 4. This 9 makes this an 8. And we're just doing normal Sudoku here. Remaining digits in row 6 are 3 and 7. They could be either of them, though. 3 or 7, 3 or 7. Okay, the remaining digits in column 2 are 4, 7, 9. Okay. Well, this can't be 4 because of that 4, so this is 7, 9, 4, 7, 9, 4, 7, 9. Remaining digits in column 3 are 2, 5, and 8. This is 2 and 8, then 2, 5, 8 here, 2, 5, 8 here. Oh, this 5 means this can't be 5. Therefore, it's a 3, which makes that a 5. This 3 makes that not a 3, so that's 7. This is 3. Remaining digits in column 7 are 2 and 7. Remaining digits in column 9 are 1 and 9. And this can't be 1, therefore it must be 9, which makes that a 1. This 9 means this can't be 9 here. This can't be 6 because of the 6 in the column. The only digits remaining there are 7 and 8. The remaining digits in column 5 are 3, 5, and 6, but this can't be 5 or 6 here, which forces this to be 3. This can't be 3 because of that 3, so this is 8, which makes that a 3. 3 is only consecutive with 2 out of 2 and 7, so this is 2, which makes that a 7. This 2 means this can't be 2, so this is 9, which eliminates the 9 here. This can't be 8 because of this 8, so this must be 7, which makes that an 8. This can't be 8 or 2, so this must be 5. This can't be 5 or 8, so that must be 2, which makes that an 8. This 2 eliminates that 2, so that's a 4, which makes that a 2. This can't be 4 or 7, so this is 9. This can't be 7 or 9, so this is 4. This has to be a 7 then. And that leaves this as a 6, and then that as a 5. And that's how you solve it. Pretty cool. Pretty cool use of the Ren bands and the German whisper lines. And the Kropke dots, I guess. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.